Hello friends, welcome to my channel Code for Self, and today we are going to discuss about A.C.I.D properties. So basically this is the DBMS tables transactions related principles and concepts, and we will discuss more on it. But before proceeding, I will request, if you are new to the channel, please subscribe the channel and like the videos and put your comment and share it so I can see your support. Moving to the next. So A.C.I.D. So A.C.I.D is basically for managing database transactions. It is having four concepts. So first one is atomicity, second one consistency, third isolation, and fourth is durability. So these all four concepts make it A.C.I.D. So so basically, ACID properties are crucial for ensuring the integrity and reliability of database transactions. So whole purpose of ACID, why ACID comes, because in database level there are different transactions that we deal with, but at the end of transaction or during transaction we have to make sure two things. First one is integrity and second one is reliability. So in integrity we will check my data is complete and correct, because any transaction is started, then data should be, my transaction should be complete, and as a result my data should be complete and it should be accurate. And second one is reliability, where we check the value is same across all tables and databases, because in multi-system transactions you deal with multiple the transactions deal with multiple databases. So at the end all my databases and tables should be in sync. So basically why ACID principles needed. So I have two examples to discuss over here. Let's suppose at DBMS there are two main type of transactions happen. First one is single transactions. So in single transactions we refer the series of one or more database operations resulting in one actions. So that is called single transactions. So that is let's suppose it is completed successfully, okay, and once complete the transaction is accepted and can be found in transaction logs. So in simple word, if I say, a common example is let's suppose if we go and withdraw the money from ATM. So withdrawal is, even though it is updating the data in different tables at the back end, but for end customer it is basically one single transactions where they are just withdrawing the money from his own account. So the dealing is happening with one account only. Now go with the multiple transactions. So multiple transaction is basically example where let's suppose one account, the amount of one account is being debited and it is being credited to another bank account. So basically here we are going to deal with two different uh, systems, but my data should be consistent and we have to make sure that my data should be the correct, and that's why it is called multi-transactions. Here we see the uh, the multi-transaction consists of multiple interdependent transactions spread across multiple databases and distributed systems. So record of these transactions also found in transaction log. An example, as I said, it is basically withdrawing, basically um, transferring money from one account to another account. So um, what ACID principles give us a kind of surety. So ACID transactions provide a level of transactional guarantee that many regulatory agency requires, because I need my data should be correct and integrity and its accuracy should be the correct. Now let's go with the next. So ACID design principles, we have A, that is called atomicity. So what this whole means? So basically my entire transactions takes place at once or does not happen at all. So basically that is called atomicity. If my transaction is happening, let's suppose it is on the flow, so there are two ways only, there is no gray area. either black or white. So either it will happen successfully, otherwise nothing will happen. Okay, it will totally roll back. So that is called atomicity. Consistency, my database must be consistent before and after transactions. So let's suppose if I am going to deal with two accounts, all are having 500 as an starting before transaction amount. So my total is 1000. Now from one account I have debited 100 rupee, so it become 400, but my next account I have credited 100 rupee, so it becomes 600. But after completing the transaction, if I add 600 and 400, it should also be the same 1000. So I can see before is 1000 and after is 1000. That is called consistency. Now let's come to isolation. So in isolation, multiple transactions occurs independently without interfering each other. So that is called isolation. There are parallel transactions in a bank account. Just imagine there are parallel transactions are happening, credit, debit, and a lot more, but they are not interfering each other. Whole thing are well covered and there is no data loss, and that's the way we will see in isolation. And durability is basically the changes of a successful transactions occurs even if system failure occur. Okay, so just we will ignore the last statement, that is system failure occurs, that because that may confuse us. Whole thing is after happening the transactions. So let's suppose if transaction happen, if my transaction got committed, so after commitment, if it is saved in my table, then it's it is for every time. So it is not like within transaction it will be lost, it is for every time. Even if after commitment there is some failure occurred throughout the system at any place, even though my data will be the same and always persist, that is called durability. Now let's go and see the atomicity. So as I said in the first slide, atomicity means that an entire transaction either take place all at once or does not occur at all. It means that there is no midway, and that is called atomicity. So if here we can see we have a two transactions, so one is T1 and other one is T2. So if T1 happen, okay, this is my T1 path. If it is happen, then it will become 400. If T2 happen, it will become 300, and that the way it will go. But let's suppose any error occurred. So what the end? If first thing is, if everything is good, then what will we do? It will do commit. And if commit happen, everything is good. But if any error occurred in execution of any of transaction, then my entire transaction will be rolled back. So entire transaction rollback means it will roll back T1 and T2 both, and they will go on their initial state. So that is called atomicity. Now let's move to next, consistency. So as I said, before occurring any transaction, so let's go with the statement that is written here. So consistency means that we have to maintain the integrity constants so that any given database says consistent before and after the transaction. Okay, if we refer to an example discussed above, then we have to maintain the total amount before and after the transaction. So this is my before. Okay, this is my basic before, where 500 and we have a 200, it becomes 700. But if I uh, reduce the 100 here, it will become 400, and plus 100 here, it will become 300, that is again is 700. So it means that my before and after both are same, so I have, we are good, and my data is consistent, that is called consistency. Now let's move to next. So isolation. So isolation is basically to prevent transactions from affecting each other. Transactions need to be executed serially for isolation. Okay, relevant and affected data sets are logged during the transaction until the transaction succeed or fails. Okay, so let's see, we have another example of one transaction that is known as T1, another transaction that is known as T2. So T1, what exactly it is doing, I have started with amount that is A is equal to 500, my B is equal to 500, my T1 will read A, so it will be 500, and now A, it's going to multiply by 100, so my amount will be here, is it called, it is like 500 multiplied by 100, and if it go write A, okay, now it is going to read B, okay, B is, that is 500, okay, and now it will be minus 50, so it become 450, okay, that is here, okay. But let's suppose parallelly, because these two transactions, my T1 and T2 is running parallelly, so in between, let's suppose my T2 also start, T2 reads A, so A value it will go to this one, because till here we have started. Now it will read B also, so maybe it can read B with its initial values, because this transaction doesn't know that it is going to reduce by minus 50. So, and at the end, whatever the compute property, that is A plus B, it will be wrong, because it is referring its initial value, not the exact one. Here isolation takes place, and isolation makes sure that all the transactions which are happening, that is in the isolated way and not interacting with each other. So my result will be the same in and correct in this scenario. Let's go with the durability. So durability is basically the durability property states that once the execution of a transaction is completed, the modification and updates on database gets written on the stored in the disk. Okay, so now this one is important line. So this persist even if the occurrence of system failure. Okay, once it stored into the disk, it is permanent, it is not going to that is erase. Okay, and even my system also, somewhere my system also get failed, that is not a problem. Okay, let's go with the next. Such updates becomes permanent and get stored in non-volatile memory, thus the effects of this transaction will never lose. So this is all about durability, and this is all about our A.C.I.D principles, about four principles we have seen. Now next, move to some interview questions. Friends, I have shared it with you, and there may be the further more, but to revisit our concept also, I have created this and wants to share it with you. Okay, so let's go with the first one. So first one is, it is asking which acid property ensures that the transaction is treated as single unit of work. Okay, means if either fully completed or fully failed. Okay, so in case of fully completed and fully failed, we have already seen, I hope you also be with me, that is atomicity. Okay, that is fully completed or fully failed. Now move to the next. Which acid property ensure that data remains in a valid state before and after? So if something comes before and after, then our consistency comes, because that is for before and after. Okay. Now next. Okay. Which acid property ensures that once the transaction has been committed, it will remains committed even if there is system failure? Then that's what we have checked, that is durability, and correct answer is durability. Fourth one, which acid property uh, guarantees that concurrent, okay, so which acid properties guarantees that concurrent execution of transactions will result in a system state and would be obtained if transaction were executed serially. Okay, so here our answer is that is isolation. Okay, so with isolation we can make sure it. Okay, so we have a fifth one. If a transaction causes an update to the database that cannot be rolled back, which ACID property is at risk? So it is asking that, let's suppose if causes any problem, okay, and it cannot be rolled back, so which property will be in risk? So our risk will be automaticity, because my one database I can see, or one table I can see record is there but other is not, and that's violate the atomicity, and this is my correct answer. Okay, so friends, thanks again for watching the video. Again I will request, please subscribe the channel, and I will keep posting more informative video. Thank you so much.